Hey everybody, welcome to week 6, audio coding with SuperCollider. How's everybody doing? So this week we're going to focus on MIDI, specifically getting MIDI data into SuperCollider and using it to make sound and do other things. Morning. Hey Cody. Morning B. Hanks, Rianto. All right, quick sound check like we always do. So left and right. Hey Jumbo, hey Justin. Digital piano with USB. I mean it's if you've used that piano with your computer before and you've like gotten notes into whatever software like Finale, Sibelius, whatever, then it should be absolutely fine. Yeah, so if you're gonna follow along, you got a MIDI controller, you want to plug it in before you open SuperCollider. I think it might work if you plug it in after, but I think I've seen a couple of situations where you plug something in after SuperCollider has opened and it doesn't do a scan for new devices. So if you might want to quit SuperCollider, make sure it's plugged in, and then reopen it. Probably a good idea. Okay, so I've got two MIDI controllers plugged in today. I've got this little Korg Nano, and I've got this M-Audio Oxygen 49 keyboard controller. So really, any MIDI controller is going to work. I mean, they're all kind of different from each other. I mean, this is kind of this keyboard. The Oxygen 49 is kind of like a standard keyboard controller. So it's got piano keys. It's also got a bunch of individual faders, knobs, and then it's got these pads. It's got pitch wheel, mod wheel. And the Nano controller doesn't have, a piano keyboard layout or anything. But whatever you've got, if it can enter notes into like notation software, then it should be fine. So anyway, the MIDI in SuperCollider it's pretty well designed. There's a reference file called using MIDI, I think. Yeah, guide file. So this is worth a read. It kind of gives you an overview of all the MIDI classes. Primarily, we're going to be using, I think, MIDIDef, but we'll get into this just a little bit later. So I think this is definitely worth scanning. Maybe not now, but when you sort of dig into some of these exercises, it's good to just read this help file, get a sense of how it works. And on all three platforms, Mac, Windows, Linux, MIDI and SuperCollider is basically designed to piggyback on your operating system's interface with external MIDI devices. So if in Mac OS, for example, there's a utility called Audio MIDI Setup. And so there's this MIDI Studio window. If you don't see it, you can go to this MIDI Studio, or what is it? Window Show MIDI Studio if you don't see that. And this is basically every MIDI device I've ever plugged into my computer. And you can see that the Oxygen 49 keyboard controller is there, the Nano Control. Also, my Motu is technically a MIDI device. So they're all awake and plugged in. So this, I think on Windows, it's something called Port MIDI. I don't know what's on Linux, but if you see devices in your operating system, then you're pretty much good to go. And so in SuperCollider, MIDI is not a server thing. There's no audio involved necessarily in MIDI, so you don't have to have the server booted for this. The quickest and easiest way to get SuperCollider to start talking with your external devices is to use the MIDI in class. So all caps MIDI and then in with a capital I dot connect all with a capital A. And this will basically say any and all MIDI devices that are currently connected, let's open channels for communication. And I think you should probably see some text here. I think this is because I've already done this when I was preparing the stream. Let's see if I can undo that. Do that, and then connect them again. Am I going to see something now? Let's see. What if I do? Okay, there we go. The MIDI in connect all step will also secretly run this MIDI client.init step. So it's not necessary to do both of these. I just wanted to run MIDI client.init to see the information that gets posted. And that's good news, Cootie. Glad to hear it. So when you run MIDI in.connect all, you should see a list of sources and destinations. And I'm just confirming that I've got it sees the oxygen and the nano control as sources of MIDI information. That's all I really care about right now. You might see some other stuff here, but whatever controller you've got plugged in, you do want to see it here as a source. So this is an optional step, but this will connect all MIDI devices to SuperCollider. That's the first step. I'm going to clear the post window. And so to actually, does it work yet? No, it does not. Doesn't do anything. But we are able to establish some back and forth data. And there are two classes that allow you to get specific data from messages into SuperCollider, and they are MIDIFUNC and MIDIDef. They're similar. They're slightly different. I prefer MIDIDef because the syntax is basically exactly the same as synthDef. And there's a bunch of def type classes throughout the SuperCollider language. And, so that you have like something def.new, a symbol name, and then a function to do something. Like this is the same syntax as synthDef, and there's also tdef and pdef and oscdef. There's a million defs. So I like MIDIDef. We're going to focus on that. MIDIFUNC is very, very similar. The main difference is instead of providing a symbol name, we actually say something like this. So basically with MIDIFUNC, why am I saying something? Let's just say, MIDIFUNC. We have to actually manage the global variable names if we want to keep track of these things to destroy them later. But MIDIDef, you don't need to worry about global variables. So let's focus on MIDIDef. So we'll get a MIDIDef ready. Awesome, that's great. Hey Marsh, glad to hear it. We'll do that in just a second, but there's a really good debugging tool just to make sure you've got data flowing into SuperCollider, and that's MIDIFUNC.trace, and then in parentheses, true. So when you run this line, it basically causes SuperCollider to just print all the data for every single MIDI message that comes in. So at this point, if you were to sort of mash your keyboard or something, you'd see tons of data come in. I'm going to be a little bit more methodical. So I'm going to hit what I think is middle C and just hold down the key. And I see nothing. There we go. Okay. Maybe I didn't reconnect. I think I disconnected all, and then I did this MIDI client.init step, but I never actually reconnected. So now we're working, because now we're connected. So that is 2 octaves up. So I'm just going to clear this, hold down middle C, and it says MIDI message received type note on. There's this lengthy source integer, channel, number, and value. And now I'm going to release it, and it says MIDI message received type note off. It's got the same source ID, the same channel, the same number, and a different value. So it's useful here if you've got a little bit of an understanding about really the basics of the MIDI protocol. MIDI protocol is a digital communication protocol for musical instruments and computers, invented in the 80s. And this is like a really basic, a very stripped down kind of tree of the MIDI protocol. So all MIDI messages kind of divide into channel and system, and those subdivide. And the only ones we really use, maybe 95, 98% of the time, are these voice messages. So that includes note on, note off, control change, program change, pitch bend, and then the aftertouch. When we press you might see something different. Maybe you'll see control, for example. Like I'll press a button on my nano control and clear the post window just for a little bit of clarity here. So down, and it says message received, type control. It's got a different source. It's got the same channel. It says number 32, value 127. Then I'm going to release it. We get almost the same thing, except the value is 0. So there's 5 pieces of information. The message type, the source ID. This is a unique integer associated with this particular device. I think if I had 2 nano controls set up, they'd be exactly the same, but they'd have different source IDs. Channel, some MIDI messages are sent on a channel, and there are 16 MIDI channels. And we as human beings think of these as 1 through 16. But computers think of these as 0 through 15. So this can be a point of confusion. So we practically speaking, this is on channel 1, but when we talk to SuperCollider about MIDI channels, it has to be 0. And then all controllers have a controller number associated with them, and they output a value. So these buttons, this one is number 32, and I just press it down and up, and it gets a value of 127 when it's down, 0 when it's up. I'll press a different button. This is controller number 38. This button is 69. This fader here is just controller number 3, and it's got a more continuous range from 0 all the way up to 127. And kind of 0. All faders kind of do that. So instead of a toggle, this is like a continuous sweep. And, back to our numbers. So it's all pretty basic stuff. So in the case of a note message, the number is, what we call the note number, where 60 by convention is middle C. And then the value is how hard I press the key. So press it really hard, we get the maximum value, 127. If I press it more gently, we get a value of 37. The key to remember, this is really important here, is that MIDI is not sound. MIDI is just numbers. And by convention, commercial MIDI software, sort of synthesizers that respond to keyboards and stuff, they're all designed to respond to note-on messages by generating an audio signal. And they're designed to respond to a control message by changing some parameter, like a filter cutoff frequency or something. But, you can very easily conceptually decouple the MIDI data from the actions that are taken in response to the MIDI data. So as we'll see, right? We don't have to, a note-on message doesn't have to make sound. It can do anything. So we set this to false, and this turns off debug mode, so we're not flooding the post window with information, and we'll clear the post window as well. Okay, so that's this is a really handy step when you first plug in a new controller. You want to just see what kind of data is it sending. Is it control messages? Is it program change messages? Whatever you have, it's going to give you some good and valuable information. Sometimes a little bit hard to read because of how much data is being sent sometimes. Like some controllers send just tons of MIDI messages on like many different channels and stuff. But anyway, let's get into it. So this is, put a comment here. This is like debug mode. Okay, let's make a MIDI def. Instead of MIDIDef.new, we can do MIDIDef.new, but I prefer to use one of the more specific methods to tell the MIDI def which type of message we're going to be receiving. So instead of doing new, we can do a whole bunch of, like for example, we can do MIDIDef.cc, MIDIDef.note on, MIDIDef.note off. So I'm going to do MIDIDef.note on. We crack open a pair of parentheses. First thing we need to do is give it a symbolic name. I'm just going to call this on. It can be whatever you want. It's just a name to help you remember. Maybe we'll call this on test. I'm just gonna do on. And then we crack open a set of curly braces for a function. And the function is going to define some code to be evaluated whenever this type of message is received. So a very simple thing we can do is say hi and post line, right? So we'll run this MIDI def, and now whenever you cause your device to send a note on message, we see hi in the post window. Hi, 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 hi. Right? Very, very basic, keeping it very simple. Also pretty useless, but proof of concept, right? So we've successfully gotten SuperCollider to listen for note on messages and do something when a note on message is received. All right, so instead of that, maybe we want to post the information in that MIDI message. So how do we do that, right? How do we get access to that? Well, we need to declare some arguments. Now, unlike SynthDef, where we have kind of complete freedom with regard to you know, how we want to configure our synthesis and how many synthesis parameters we want to declare and what kind of inputs and outputs we want. So we can make whatever arguments we want. But in a note on MIDIDef, there's a specific collection of arguments that is expected because it's a note on message. There's a note number, there's a velocity, there's a source and source ID, there's a channel. So let's go up to this. If you go up to mididef.new in the MIDIDef help file, you can read this description of the function input. So it says, when evaluated for note on, note off, control, and polytouch, it will be passed the arguments val, num, chan, and source, corresponding to message value, for example, velocity or control value, message number, MIDI channel, and MIDI source. So let's go ahead and do that. Val, num, chan, source. And we are just going to make an array containing these arguments and post ln. And so now, press a note, and we get those 4 values in an array. We get the note velocity, 127, note number, which is 60, channel 0, and its source ID. So this will work for whatever keys we press. Right, so all those values are coming in, and we now have access to the data that is contained inside that message. So instead of just posting a random unrelated string. Now, and you don't have to, these names can be whatever you like. So we can call them ABCD and say ABCD dot post ln, and the result will be exactly the same. But we can't really change the order in which the MIDIDef expects these arguments. So the first one is going to be the value of the message. The next one's going to be the number of the message. You know, like the note velocity, note number, channel, and source. So it's in your best interest to give these names so that your code makes sense instead of just, you know, ABCD. So if you're following along and you've got a controller that sends note messages, you should be able to get some values, right? Hopefully some of you are able to follow along. So the Korg Nano doesn't do anything because this is not sending note on messages. It's sending control change messages. So I'm going to just copy this, make a new MIDIDef, and instead of note on, we're going to say CC, and we're going to call this CC. And we can keep everything else the same. The only difference now is that this MIDIDef is going to respond to control change messages. So now, if I move this fader, we can see that's controller 0, sending its values, controller 1, controller 2, 3, 4, 5, 6, etc. These knobs, this is controller 22, this is 23, this for some reason is 61, 24, 26, 27, 62. So now we're starting to get going here. So let's actually do something with these values. Like, why don't we'll say let's actually make a sound, right? So let's boot the server. Looks good. And let's copy this. If you ever want to start fresh, just kind of take all your MIDIDefs, just make them vanish. You can say mididef.freeall. And so this, now all our MIDIDefs have been destroyed, and SuperCollider is not responding to MIDI messages anymore. It's still connected, but we've just destroyed all of the functions which tell it to do something specific, like post values. Okay, now we booted the server. We can keep that line there. And let's do something really basic. Sine osc 1000 with an amplitude of 0.2 and play that. So maybe you can anticipate what the problem is here. Let's press a key. Let's press another key. Okay, command period. Let's command period that. Let's bring up our scope just so we can see that. Oh, I should also add that command period will command period does many things. It wipes all the nodes off the server. Another thing it does is it destroys any non-permanent MIDI Deafs. MIDI Deafs are non-permanent by default. You can change that if you want by saying .permanent_true at the end of your MIDI Def. And this way you can press command period and it will survive command period. You can always, so here, like if we do this, press a key, here we go, here we go. Okay, quite enough of that. Sorry, that's not the best frequency for this, but so now command period, the MIDI Def is still around. We can free it manually by saying MIDI Def on. Sorry, this is obscured by the chat. Sorry about that. .free. So this is instead of free all, we can find a specific MIDI Def, refer to it by its symbolic name, and say free. So now, no more horrible 1K tone. Right. The problem with this is this function has no amplitude envelope. Right? There's no. It's just a tone that we create that, and then we give ourselves absolutely no way to control its duration or end it. So we could say, let's make an envelope. Just say env.perc .action2 sig equals sig times env, and play that. And now, another thing I really like about the MIDI Def objects as opposed to MIDI funcs is that you can overwrite them by just changing their contents and reevaluating them. And the old MIDI Def stored at the symbolic name on is just replaced. So it's just one overwrites the other. This is not the case with MIDIFUNC. You actually have to manage MIDI funcs, and it's, you have to sort of manually free it and then make a new one if you want to keep the same name. I just prefer MIDI Def. I think it's just a lot easier. You can just evaluate them without thinking about it too much. All right, so now each time we get a note on message, we make a little percussive sine tone with a fixed duration. So the next step, obviously, is to be able to play a tune, right? We're playing 1,000 hertz every time. So this is the next step, and we're gonna say we have to somehow use our note number, right? The number is because we've been posting it, and so this is 60, this is 62, 63. So instead of 1,000, we're going to say num, and we can try this, but it's not going to work right away. I mean, it works, but it's just using the note number as a value in hertz, and that's not how we conceptualize the MIDI data. We've got MIDI note number 60 corresponds to middle C, which has a frequency of like 261 or something. Note number 69 is A440, so 440 hertz. So we got to convert this somehow, and the way to do that is to say .MIDI CPS. So .MIDI CPS, for example, so 60 .MIDI CPS gives us the appropriate value in hertz. So the lowest MIDI note is 0. That gives us a frequency of 8, and the highest MIDI note number available is 127. That gives us a frequency of about 12.5K. So it's a nice big spread. So we'll say num.MIDI CPS, and now this should work. Awesome. So that is where we've sort of made it. We've made it. We're actually using our keyboard controller to produce notes in a way that's intuitive and conventional. So that is I hope hopefully some of you have gotten here. It'd be great to know if some of you are able to get your controllers to produce sound. If you got any questions, you're running into any problems, feel free to throw some questions up on the chat. Awesome, that's great. Yeah. So you can, and another great thing about the synth-defs is that you can. Oh, there's no synth-defs. Yeah. Okay. We've been doing function.play, and it would be nice to convert this to a synth-def. But before we do that, I want to okay, what if we want to sustain this note? I'd like to hold this C and then release it when I feel like it. We can't do that right now because we're using percussive envelopes, and this is a fixed duration envelope object. So we have no way of sustaining. We need to change the synthesis function somehow. So let's just use some default values here and say ADSR. So ADSR is a attack decay, sustain, release, and there is an additional argument that we need to provide, which comes right after the env object, and that is a gate argument. So we're not going to use a t underscore argument here because we're not triggering a one-shot envelope here. We actually need to set the gate to 1 to hold it open, and then set it to 0 to make it go away. So and as soon as whenever I start declaring arguments inside of a function.play, that's when I know I should be making a synth-def. So we are going to actually extract this, and let's see, I'm going to copy and paste this so it's easier to upload later. So I am going to take this sound function, and we're going to do a synth-def. We'll call this tone. Paste that function, and we're not going to play it. I guess I don't need, I'm having duplicate brackets here, so. All right, we need to make a couple of changes here. So let's make arg freak, default it to 440 for no reason. Let's make an amplitude argument, a gate argument, and an output bus. So here's our amp. We're just going to say freak here. And we got gate, and then we need to add our out. Okay. Just so we've got 4 arguments: frequency, amplitude, envelope gate, and output bus. We've got a signal, which is a simple sine wave, amplitude scaled with a customizable frequency, ADSR envelope applied to the amplitude of the signal, and then we send it out. So that looks good. Now, instead of doing a function.play here, all we need to do is say synth.new, tone, and then provide whatever arguments we need. So we'll say freak is num. I'm going to space this out a little bit. Num.MIDI CPS, right? The note number converted to cycles per second. We'll keep amp at 2, but we could take the note velocity and put it in here and scale it appropriately. Maybe we'll do that in just a second. Gate 1, because we actually want to open the envelope and let the sound through. Out 0. And we don't need to worry about any sort of target add action because we're not doing any effects. We're not doing any in.ar. So let's, we could do this. I think this will work. But we have not really completed our job here because nothing is listening to the note off message, right? Command period. So we've got to make a second MIDIDef, one which responds to note off messages. So we'll call this off and pass the same arguments in. I guess we'll post these. It doesn't really hurt to post. And now we need to do something which sets the gate to 0. So we need to give this synth a name. So maybe our first instinct would be like, okay, let's just call it sound. And then here we say sound.set gate 0. And naively thinking, okay, yeah, maybe this will work. I'm gonna unpermanent this and say MIDIDef.freeAll. I don't really want them to be permanent. I'd like to command period them and clear them away easily. Okay, so let's just examine this here. We've got our synth-def. It's got its arguments, and we've got these two MIDI defs responding to note on and note off messages. One of them is creating a sound, calling it tilde sound, and the other one is setting its gate back to 0. So let's give it a try. So that seems like it's working, but watch what happens when I'm going to press a note, hold it down, press a second note, hold it down, and then release one of them, and then try to release both of them. So we'll do C, and then we'll do D. So that all seems fine. Now we'll release D, and now we'll release C. Aha! Failure in server, node not found. All right, so let's command period that, and let's just think about this for a second. We got a stuck note. It doesn't really make too much sense. Let's try it again. Let's go, and now we'll release one of them. It goes away. Let's release the other 4. Doot, 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 doot. So we can only release the one of them. So we make, if we press that first example, we hold down a C, hold down a D, and then release one of them, and then the second one gets stuck. This is happening because we make a synth called sound, and then we get another note on message. So we make another synth also called sound. So tilde sound only refers to the most recently created synth. So when we get a note off message, it releases the most recent synth. But then if we get another note off, it says, oh, sound, I already released that one. It doesn't exist anymore. And we've been overwriting multiple synths with the same variable name. So this is bad. It's not good. It's the wrong way to do it. It's fine as long as you don't overlap any notes. But of course, that's ridiculous. Why, we want polyphony. We want to be able to hold down multiple notes, play chords, whatever, right? So this is not going to cut it. We have to do something a little bit more elegant to manage being able to deal with multiple synths. And the way to do this is to conceptualize it differently. We have theoretically 128 unique note numbers that could theoretically be played all at the same time if you had a MIDI controller with more than 88 keys. I guess it's pretty unrealistic, but just from a very abstract point of view, 128 unique note numbers. So theoretically, they can all be on at the same time. And so we need to be able to accommodate those 128 unique synths. And so the right thing to do, or one very good thing to do, a good approach, in my opinion, is to make an array of size 128. And we'll initially just fill these with a whole bunch of nothings. So now we have an array called notes. Its size is 128, and it's empty. It contains a bunch of nils, but it basically doesn't have anything in it yet. And let's copy these. And we're going to do a little bit of modification here. We're going to use num as we have been using it to convert to a value in cycles per second so we can produce the right pitch. But we're also going to use num as an index into this array. So we're going to, instead of just saying sound equals synth.new, we're going to say notes and then square brackets at num equals synth.new. Right, so I'm just changing some white space a little bit, but whenever we get a note on message, we're going to say make a new synth and set it equal, you just basically store it at in the notes array at the index determined by the note number. And so it's not possible to press the same note down twice without releasing it. So there's no risk of overwriting anything. Every note kind of has its unique cubby that it belongs in whenever we press it. You can actually think of the keyboard layout as our array, right? And so we're putting a synth here, and we're putting a synth here, and we're putting a synth here. And then it's sort of partner in crime here, the note off message, we're going to say notes at num dot set gate 0. So when we get a note off message, we say, oh, okay, so we're getting a note off message. That must mean there is a note at the index num. So we're going to set its gate to 0. And I think this is technically kind of an optional step, but we can say notes at num equals nil. This is probably a good thing to do. So as soon as we set the gate to 0, we on the sort of language side, we say, okay, that item is now nil because we've sent a note off message, so there's nothing there anymore. And this might be useful if we were going to do something more complex with we want to know at any given point in time how many notes are being held down. If we didn't do this step, then we would just have a bunch of synths that are technically off the server, but they're still the language side representation of them is still stored in the array. So I think this is a perfectly good thing to include. And this ought to do it. So let's try it. Oh, that's awesome. Okay, yeah, it works. Turn the octave up a little bit. Yeah, so we've got a 128 voice polyphonic synthesizer right now. So instead of setting to nil, could we use done action 2 somehow? Well, the thing is, we're already using done action 2. When we set the gate of one of these synths to 0, let's go back to our synth that causes the env-gen to begin its release phase, and at the end of the release, the env-gen checks its done action, and if it's 2, it frees the synth. So here, let me give you an example here of let's take this away. Let's comment this out, and we're gonna reinitialize our empty array. And so I'm going to play a note, and then release it. All right, so it seems fine. And if we check the node tree, there's nothing there. There's nothing in the default group. This is just our stethoscope. So it definitely got released with done action 2. But if we check our notes array, there's still a synth at index, whatever that was, whatever note that was, 30 or 40 something. And this is a little bit misleading because we could say, notes. If we were to ask the array, how many non-nil objects do you have? It's going to say, I've got 1. But that's not consistent with what the server sees. So this is why I think it's good. By done action 2 manages the collection of synths on the server, but it's good to manually kind of take the wheel and also manage the language side representation of what's on the server by whenever you free a node on the server, also set its representation on the language to nil. So if we do this and then do this, so now if I hold a note, we can, while I'm holding it down, we can check notes. So there's our synth. And if I release it and then check notes again, it's gone. So I just think this is more consistent, more elegant. Not absolutely necessary, but depending on what we're doing, we might run into problems if we don't keep our language and server representations of our synths consistent, if that makes sense. Let's incorporate the velocity, right? So value, just as a reminder, it's this first number in the array, or technically the 0th number in the array, and it's how hard I'm pressing the key. And also, there is a velocity associated with note off. It's how quickly you release the key. So I can sort of hit it hard, release it quickly. It actually, I just got a few extra messages there. It kind of like ricocheted a little bit. That's this controller's, it's maybe could be designed a little bit more robustly. But if we sort of press it gently, release it gently, that's a low velocity. And then press it hard, release it hard, we get a higher velocity. So we can, I'll answer those questions in just one sec. So we're gonna say amp val, and you better do something here so that we don't just plug the raw velocity values in, because these values range from 0 to 127. And we don't want an amplitude of 127. That's gonna hurt our ears. So we're gonna say lin x. We're gonna map numbers that come in on a linear scale of 0 to 127, and we're gonna say if we get actually technically we're never gonna get 0 because we're pressing the note down. So I think I think different devices respond differently. Like a note off is considered a velocity of 0, but that's not how this controller works. So I think 127 is fine. 1 to 127. So a velocity of 1 is extremely quiet, so like maybe 0.02. And 127 is the highest we can get. But I don't want to put a 1 here, because then if we play two notes with velocities 127, they're both going to be sounding simultaneously. They're both going to have an amplitude of 1, and that's almost certainly going to clip above 1, and that's going to turn the level meters red. And so I think I'm just going to do a more modest value here. So basically a 127 will become a 0.3, a 1 will become a 0.2, and we need a comma at the end here. And so now we should have volume control based on velocity as well. Sweet. Okay, so since we've created our own array, we essentially need to keep it clean ourselves. Yeah, right. That's kind of the theme you see a lot in the language. Whenever you're creating things and giving them global variable names, you just have to manage that. I mean, not just the contents, but also you need to make sure you don't call something else notes and overwrite it. And yeah, just kind of make sure if you're going to create these data structures, you've got to make sure you manage them. If the array fills up, will we no longer be able to play anything? Well, the thing is, it's got 128 slots, one for each possible note number. They can be as low as 0 and as high as 127. There are no notes beyond that in the MIDI protocol. There's no. So it's impossible to make a 129th note. So it's kind of like, it's like, what if we play an 89th key on a grand piano? It's like, well, that's impossible. That what if we don't have strings for that? It's like, well, of course we don't. It's just not. It's not how the piano is designed, and so this is not how the MIDI protocol is designed. There are 128 discrete note numbers, and yeah, so that's just not a concern. The array might fill up, but that means we're pressing all the notes we can possibly press, and the only thing we can do at that point is release some of them. All right, so this is we've got our basic structure here for polyphony, and it's working pretty well. I mean, I don't think we're getting any stuck notes. Oh, I see. If we don't replace them with nil, no. If we don't replace them with nil, it'll still work fine. So like as we saw earlier, if without this step here, we play a note, we release it, it's off the server, but it's still in the array. If we then play the same note again, it's just going to replace, it doesn't care what's currently in that index, it's just going to replace it with a new synth. And then if we release the note, we set its gate to 0. So it's just, we'll never see nil there again. We're always going to see a synth. And we don't know how recent or how old it is. But that's perfectly fine. So if we do this way, we reinitialize our notes array. So we'll play this note and release it. So there's our synth, but we can still play that note. And it so the one we just saw was I guess node number 1368, and now it's 1369, and now it's 1370. So there's really no harm being done. I think it's just sloppy practice. So I like to say nil. So whenever we release a note, we can at any point look at our notes array and say, okay, we've got nothing there. It's not really posting the whole thing, but if you want to post the whole thing, I think you can say notes.post cs, and that will post the entire compile string. So here is our entire array. It's a little trick. Yeah, it's just housekeeping. That's right. All right, so the last thing I want to do is use some controller, right? So we have this mod wheel, we've got all these faders, but we're only listening to note on and note off right now. So what I want to do is do like the very sort of classic thing, which is to use the mod wheel to do a little bit of vibrato, you know, so vary the frequency. So instead of buh, we get buh. So the first thing we need to do if we want to do this is to modify our synth def. Because right now we just have this static frequency value. But we are going to do, we're going to make a signal called vib. Vib is equal to another sine-osc. It can be a control rate sine-osc because it's not going to be moving very quickly. It's just going to be controlling the frequency of the signal we're actually listening to. 6 or 7 hertz is a good value for a vibrato, right? If we go too high, then we just start to get modulation artifacts. And if we go too slow, then it's this, so it's what we think of as vibrato is around 6 or 7 hertz. And we're going to say range, and I'm going to think of this in terms of semitones. So I think a vibrato, a sensible value is like maybe a quarter tone. We'll try this. So we can say range by the sine wave will go as low as minus 0.5 semitones and as high as positive 0.5 semitones. If you find yourself specifying range as a sort of the same number but negative and positive, you can also say bipolar, 0.25. It's just the we did 0.5. Same. So this is the equivalent of saying range minus 5.5, bipolar 0.5. And then what we need to do is incorporate it here. And what I'm going to do is convert this from a value in like MIDI note numbers, semitones, to a ratio. So we've seen this before, I think, on the stream, which is a MIDI ratio takes a value in semitones and turns it into a frequency multiplier. So a value 12 becomes 2, 24 becomes 4, 36 becomes 8. So, 0.5 is a pretty small amount. 0.5 MIDI ratio gives us 1.02. So a little bit higher than the starting value, and this one's a little bit lower. So we just say freq times vib. And let's, we want to be able to control the amount of vibrato. So let's just play this synth for now. We need to say gate 1 because gate is 0 by default. Gate 1. And there's our vibrato. And I didn't give this synth a name, so I can't set its gate to 0, so I'm just going to hit command period. So if we have this 0, then the amplitude of this sine wave is 0, so there will be no vibrato. Say x equals. So if this is 0, no vibrato. This is 0.2, we get a little bit of vibrato. And if it's like 0.9, we get a lot of vibrato. And if it's like 20, then it's completely ridiculous. Okay, let's say vib amp. And vib amp equals 0.3 by default. Doesn't really matter, it's just a default value. So now we can do stuff like this. X.set Vib amp 0. So it's off, it's on, it's extreme. Okay. And just keep this here for posterity. Okay. So we've modified our synth def. That's good. And now we need to modify our MIDI handling code. Let's see. I'm gonna copy this. I should have copied and pasted this synth def, but I'll paste it down here just for good measure. Let's see. I'm just gonna clean this up just a little bit. Okay, so now we're gonna do with vibrato. All right, so we've got our notes array, right? We've got our new synth def. So let's start by making a MIDIDef.cc. And you know what? I'm gonna temporarily free all the MIDI defs just for clarity, so we can focus on this MIDIDef.cc for now. We'll give it a name, call it vib, and arg val num chan source, val num dot postln. Okay, so what did I forget? I forgot a comma. Need a comma there. Okay, so this will, if we move this controller, there we go. We've got our data coming in, but you'll probably notice that it responds to every CC message because we haven't specified otherwise. We just say, hey, if you get a CC message, post the value and the number, right? So, but this mod wheel, by convention, usually has a control number 1. But you, whatever controllers you've got following along with, you can just pick any controller and just see what number is associated with it, and then use that. So the nice thing about these MIDI defs is that after the function, we can put a comma and then specify a number, and that will cause the MIDI def to only respond to messages coming in with that number. So I'm just going to say 1, reevaluate it, and now it's responding to this one, but all these other faders don't do anything, right? It's only listening to CC messages with controller number 1. So I think that would also, this one is working on my Korg Nano and the mod wheel. That's fine. We can live with that. So what do we need this? We want to do a vibrato effect. So there's kind of 2 things we need to think about here. Whenever we move the mod wheel, we might already have some synths that are active, like we're holding down some notes on the piano keyboard, and we move the mod wheel, we want to affect those synths that are already in existence. So we can do that by saying notes.do, basically iterating over the array of notes, passing in each item, which happens to be synths, and saying synth.set vibamp val.lin 0127 0, let's do 0.5. And if so, at any given point in time, notes is going to contain some combination of synths and nils. And synths know how to respond to set, right? It's just you set the vib amp parameter. It's going to come in as a value between 0 and 124 and map it onto this value in semitones. And so what if we say, you know, this means we're going to be passing the set message to some nils. So I just, it's nice to know that nil responds to set by doing nothing. It's instead of throwing an error message, which would be like arguably kind of not so great, right? We don't want to just flood the post window with error messages. But fortunately, nil understands the set message and just responds by returning itself. It doesn't do anything. So it's harmless to try to set a nil. Excuse me, try to set a nil object or something. So it's perfectly fine to just set everything in the array. It doesn't matter if it's a synth or if it's a nil. So this takes care of setting synths that are currently in existence. But what we also want to do is, you know, make it so that when we move this mod wheel, we want synths that are created after the mod wheel is moved to use this new value, right? If we start low and go high, well, let's just see where we are right now. So let's run all of these, and I think, yeah, let's just try it. Let's just try again here. So we got our notes array, just running this all just to be, this is no longer bad. It's less bad. So I'm going to play a chord, and I'm going to move the mod wheel. Okay, so it didn't quite work, but now we're low, and we have no vibrato. And now we move it up, and we have vibrato. I might make this a little bit more extreme just to really hear it. Okay, but the problem here is that if we move this down, so now no vibrato, right, we still get vibrato. If we move it up, still getting vibrato, right? So we've taken into account synths that already exist, and every time we move the mod wheel, we're going to be setting existing synths. But what we also need to do is keep track of a global variable and incorporate it into this part of the code, so that whenever we get a new synth, it knows the current state of the mod wheel. So let's go and say vib equals 0. Vib is 0 by default. I guess for consistency, let's call this vib amp. And we need to add another line here to say vib amp, vib amp. And in addition, okay, so now we're incorporating this value, but we need our CC MIDIDef to update this value whenever a new CC message is received. So vib amp equals val dot lin 0 127 0 1, and that's basically it. We can actually even, I mean, we don't really need to do this calculation twice. So here I'm just going to say vib amp. All right, and that should do it, because now we're updating any existing synths, and we're also updating a global variable so that new synths created after the wheel is moved have this new value incorporated into them. So that, I think, will give us sort of exactly what we want. And I'm just running all this again just to be extra sure. So now if I move this down, move the mod wheel down, no vibrato. And now I move it up. Now we have our vibrato. And it's controlling existing synths as well. I want the release to be a little shorter. We're using the default ADSR, which has a release time of 1. So we're going to say release. Let's say, okay, attack 0.1 is fine. Decay a little bit shorter. Sustain level 0.5. Release time 0.2. So now, yeah, okay, very jazzy. I think you'll inevitably kind of find yourself, if you have a pitch wheel, like wanting to bend the pitch. But I'll leave that as an exercise for you. It's kind of the same idea here. We would probably make a global variable called pitch bend, and you'd make a new MIDIDef dot bend, and you'd say, pitch bend, and you'd provide a function which does kind of the same thing that the MIDIDef.cc does. It sets a global variable, updates any existing synths, and you'd also incorporate into your note on MIDIDef, and you'd have to go to your synth-def and add another a way to bend it. So it's a good exercise. It's a bit challenging, but it's kind of we're doing the same kind of stuff we see in MIDI synthesis plugins, but we're kind of starting from square one and building our way up. Yeah, I think that's kind of everything I wanted to get to. This is the essence of MIDI and SuperCollider. So yeah, I'll stick around if anyone's got any questions, if anything's sort of not working as expected, or anything in the code here is not clear, feel free to ask away. Stuck notes. Hard to diagnose. Let's see, what would... I'd have to see the code. You can paste bin it to me if you want. I'll take a look. I'll put it on stream, and we can sort of work through it together. But I think you shouldn't be getting stuck notes. This kind of structure here, where you store a synth, add an array index, and then refer to that same index and set that synth gate to 0. That should, like, I think even if I really just mash the keyboard like wildly here. Yeah, no stuck notes. But yeah, if you want to send your code to me, I might be able to spot the issue. Let me grab that. All right. So let's see. We have got our notes array. We've got synth-def. Just scanning this. Looks fine. Yeah, that's all good. MIDIDef note on. Notes at num. Synth.new. Something weird's happening here. No, never mind. I'm just this looked like an argument to me, but no, that's fine. I might do that or something. Gate 1 at 0. And yeah, I mean we don't need this, but that's also harmless. Let's just run all this. Clear some of these excess parentheses away. So that I have something extra, that one. Yeah, your code looks fine, and it's working fine for me. So what kind of controller are you using? Because that's the only thing I can think of. If you are using a controller that is somehow, I wonder, oh, you know what I bet it is? Okay, my guess is that your controller is transmitting notes on multiple channels. Oh, I bet that's it. That's got to be it. So when you so what I want you to try, Cody, is just turn on MIDI func.trace true, right? So turn this debugging mode on, and then just press one key and release it. So what you should see is just one note on and one note off. I remember my digital piano, like I've got this really old Yamaha controller / synthesizer, and I remember it would send when I pressed a key and I would turn on, you know, the trace option here, I would see it on channel 0 and channel 1 and like channel 10 or something. So I would see multiple notes. And if that's the case, then this note on is not listening to specific channels. It's just letting all note on messages come in. And so if you're sending on multiple channels, it's going to be dumping multiple synths into the same index and calling. And so that'll create like multiple sounds on multiple synths on the server, but they're all called notes in the language, and so it'll only free. I would bet on this. I'm pretty confident this is what's happening. Can you confirm that you're seeing multiple note ons and multiple note offs when you press a single key? And if that is the case, if you see like you might see like you know, note on channel 0 and then another note on channel 1, channel 2. The solution is to do the same thing that we did here, filtering out control messages so that we're only listening to CC messages that have controller number 1. So we can do the same thing with note on. Extra control message. I think something somewhere somehow is sending multiple note ons. It's the only thing that makes sense. The control message wouldn't really do anything because all that's doing is updating a global variable and modifying parameters of existing synths. So I don't think the control message is going to... the only other thing is that if somehow your MIDI device is like, yeah, buggy or sluggish, or like if it's if there's some weird latency or something, so that like, yeah, I think if you try you could try like pressing a note really fast, like on off, and maybe it's like the somehow the note off is getting it, I don't know, you know, it's like the synth is already, you know, I'm not sure. I guess it could also be a computer issue. Like I don't know if you're on Mac or Windows or Linux, but or what operating system you're on. So it might just be kind of a funky. I bet there's a pretty clever solution, but I'd need to sort of be there in person, I think. Yeah, well, I can speak a lot less to how Windows would respond to this code than Mac. So, yeah, but your code looks fine for what that's worth. Anyway, if you do have a keyboard controller that's sending notes on multiple channels, you would put a comma after the function, and we don't want to filter by note number. We want to filter by channel, so we can say chan:0. And this isn't going to look any different, but if we let's take this away for a second. Whoa. And so we'll get rid of that. So now it's responding to all channels. So if I actually change my MIDI controller, so now it's sending on channel, actually, I think I need to actually say chan:0. No? Nothing. Channel. Weird. I thought this would respond to all note on messages. And so that's channel 0. Now we're in channel 1. Turn this off. All right. Well, I'm missing something obvious here, but I do know that the design of these is such that, you know, Chan, you can say Chan, say nil 0. What if we say nil 1? Okay, so now it's listening to channel 1. If we go to channel 2, it doesn't listen. If we say nil. All right, I'm messing things up here. I'm not actually sure what I'm doing wrong here. Chan integer, this can be an array. If nil, the MIDIDef will respond to messages received on all channels. Well, I'm not sure. I thought that would be the solution, where you say, okay, only listen to channel 0 instead of listening to every channel. But it doesn't seem like it's listening to every channel. So I think I'm screwing something up here. Well, anyway. Okay, I've spent enough time babbling here. So hopefully this makes some sense on using MIDI to talk to the server and create and destroy synths, make some sounds. All right, so there's not going to be a live stream next week on account of midterm exam, but I'll be back here in 2 weeks, 2 Tuesdays from now, and we're going to talk about patterns, which is a SuperCollider specific family of classes for controlling sound with very detailed and interesting and customizable algorithmic ways. It's a lot of fun. It's good stuff. So there will be an in-class set of problems on Thursday, and no take-homes until the week after that. So yeah, thanks everybody for watching, and yeah, I'll be back on Twitch streaming in 2 weeks. All right, thanks again, everybody, and see you soon.